Hi all, in this particular video we'll see sorting techniques and data structures. Sorting means the process of arrangement of elements in a specific order, preferably ascending or descending order. This process of arrangement of elements is called sorting. So in this particular video we will see simple sorting algorithm called bubble sort. Bubble sort is a simple comparison based sorting algorithm. What do you mean by comparison? It will compare two adjacent elements and if they are in wrong order, it will swap. That is the meaning of comparison based sorting algorithm. It will compare two elements in an array. That is the meaning of comparison. There will be non-comparison based sorting algorithm that we will see later. So it repeatedly compares adjacent elements in an array and swaps them if they are in wrong order. So it will scan from left to right of the array. It will take first two elements. If the first two elements are not in the wrong order or not in the correct order, I mean to say they are jumbled, it will swap. The bubble sort will swap those elements. That is the meaning of bubble sort here. Why it is called bubble sort? During each pass, what do you mean by pass? The scan of left to right of the array. Each pass, each scan, the largest element bubbles up. That means the largest element of the array will be fixed at the end of the array. It is like air bubble is rising to the surface of water. When you throw a stone at a pond or canal, air bubbles will be rising to the surface, right? It is also like that only. During each pass, the largest element bubbles up. That means fixed at the end of the array. That means we should not go to that element because that element is already shorted. That is the meaning of bubbled up or fixed. After the first pass, the largest element is fixed at the last position. After the second pass, the second largest will be fixed and the process will be continuing further. So this is the bubble sort theory. And when it comes to working principle, we will start from first element and compare it with the next element. If the current element is greater than the next, we will swap them and then we will move to the next pair. After one full pass, the largest element moves to the end of the array. We will repeat this process for the remaining unsorted part of the array, and we will stop this work. We will stop this process when there are no swaps are needed. That means the array will be shorted by that time. So this is the working principle of bubble sort. Let's take an example and see how bubble sort works internally. So we have 6 elements in this example. The elements is as follows: 64, 34, 25, 12, 22 and 11. Array size is 6. Pass 1, we will scan from left to right, and left to right scan is called one pass. Well, compare adjacent elements. As I said earlier, we will compare the adjacent elements. What are the adjacent elements from the left to right? 64 and 34. That is the pair. We will take that. 64 and 34. Is the 64 and 34 on correct order? And our motto is to sort the elements in ascending order. That means from smallest to largest. So since 64 and 34 are not in required order, we will swap them. So after swap, this is the updated array looks like 34 and 64. This is the swap. And remaining 24, 25, 12, 22, 11, we will leave as it is. Now the next thing, we will compare 64 and 25. We will compare 64 and 25. Now 64 and 25 is not in correct order. We will swap them. 34, and the updated array looks like 34, 25, 20, 64, 12, 22, and 11. Now we will compare 64 with 12. Since 64 and 12 are also not there in required order, we will swap them. 34, 25, 12, 64, 22, and 11. Now we will take another pair called 64 and 22. And since 64 and 22 are not in our required order, we will swap them. 34, 25, 12, 22, 64, and 11. Now we will take last pair, that is 64 and 11. We will swap them because they are also not in the correct order. So 34, 25, 12, 22, 11, 64. This 64 is got bubbled up and it is fixed. In next pass, we should not going to the 64 element because 64 is already shorted and placed at the end of the array. So it is bubbled up, that means fixed at the end of the array. So largest element, that is 64 in our case, is fixed at the end of the array. And at the pass 2, as I said earlier, last element is ignored because last element, that is 64, is got bubbled up. Now we will start scanning from left to right again from 0th index. We'll 25 and previously the array looked like this 34, 25. We will compare 34 and 25. Since 34 and 25 is not there in correct order, we will swap them. So updated array looks like as follows: 25, 34, 12, 22, 11, and 64. And we swapped 25 and 34. That is what we have done just now. And we will compare 34 with 12. Since 34 and 12 is not there in correct order, we will swap them. So 25, 12, 12, 34, 22, 11, and 64. And next we will compare 34 with 12, 22. Since they are not in correct order, we will swap them. The updated array as follows: 25, 12, 22, 34, 11, and 64. We'll take another pair called 34 and 11. Since they are not in correct order, we will swap them. 25, 12, 22, 11, 34, 64. We should not go to 34 and 64 because there is no use. 64 is got bubbled up. So second largest element, in our case 34, is got bubbled up. That means fixed at the required position in the array. Now we should not take 34 in the upcoming pass. So the pass number 3, from before that, please see the array 25, 12. We will take these two things, 25 and 12. We'll compare them. Since 25 and 12 are not there in correct order, we will swap them. So that is what we have done here. And we just swap 12 and 25. So 12 comes at the 0th index. 12, 25, 22, 11, 34, 64. And we will go to another pair called 25 and 22. Since they are not in the correct order, we just swap them. 12, 22, 25, 11, 34, 64. And then we will take another pair called 25 and 11. Since these are also not in required order, we will swap them. So 12, 22, 11, 25, 34, 64. Since now we should not take 25 and 34 because 34 is already bubbled up in the previous pass. So 25 is fixed now. Now what is the updated array looks like? 12, 12, 22, and 11. And 25, 34, 64 is already sorted. Now we will take 12 and 22. We'll compare if they are in correct order or not. 12 and 22. These are in correct order, right? So no swap is required. Now we will go to another pair called 22 and 11. Since 22 and 11 is not there in correct order, we will swap them. So 12, 11, 22, 25, 34, 64. 22 is fixed now. Now in the next pass, 12 and 11 will be compared. So 12 and 11 is compared now. They are not in correct order. We will swap them. So 11, 12, 22, 25, 34, 64. So this is the updated sorted array. So at the pass number 5, we have the sorted array. So what did you observe in this working principle? When we go back to the starting of the example, we have taken 6 elements. So 6 elements we have what number of passes we have got, how many passes we have processed so far, 5 number of passes. So if the array size is n, there will be n minus 1 passes. Okay. During each pass, we will compare the adjacent elements and we will swap them if they are in not correct order. So we will be requiring two nested loop approach. Outer loop is basically to process the passes. I mean for the passes. Inner loop is basically for to compare the adjacent elements and swapping. That's why we have to code it in the nested loop fashion. Now when it comes to algorithm, we'll start the algorithm, repeat passes from 0 to n minus 2, that means 0 to n minus 1. And each pass, compare adjacent elements from index 0 to n minus 1 minus I. So in algorithm, we will say n minus 2, but in code, we will say n minus 1. Both are same. In each pass, compare adjacent elements from index 0 to n minus 1 minus I. Why it is like that? Because every pass, one element will be bubbled up every pass. That is why we will write in inside loop, inner loop, n minus 1 minus I. In inner loop, we'll compare the elements, adjacent elements, with the help of if condition. If a of j is greater than a of j plus 1, that means first element is bigger than the next element, we will swap the those two elements. After each pass, the largest element of the unsorted part is placed at its correct final position. We will continue this process till all the elements get sorted. So this is the algorithm. When you convert this to pseudocode, that means the pseudocode is very similar to your working code. So bubble sort will take two arguments. That means name of the array and size of the array. So outer for loop is basically for the passes, for the scans. We'll begin the scan with I is equal to 0 to n minus 1. So in code, in pseudocode, we will say n minus 2, but code 0 to n minus 1. So there is a mathematical notation. Next, for j is equal to 0 to n minus 2 minus I, in code we will say n minus 1 minus I. And then we do check the condition if area of j greater than area of j plus 1. If the condition is true, that means they are in not correct order, we will swap them. So this is the algorithm, this is the pseudocode. And when you convert this pseudocode into code, this is the code looks like. So outer loop, as I said earlier, it is for number of passes. For I is equal to 0, I less than n minus 1, I plus plus. Inner loop basically to comparison with each pass. For j is equal to 0, j less than n minus 1 minus I. Why we will decrement minus I? Because every pass, one element will be reduced. So if you code it n minus 1, it is not the correct way. So you should be using n minus 1 minus I. So after each comparison, we will I mean, after in inner loop, we will compare the adjacent elements, and if the adjacent elements are not in correct order, we will just swap them. So that is the meaning of bubble sort here. Now we will code bubble sort in one coding platform called Instax. Now we will code the bubble sort. So as you see here, we have sample input and sample output. If the array size is 5, suppose we have given 5, 1, 4, 2, 8. After the sorting, the sorted array looks as follows: 1, 2, 4, 5, 8. We have to sort this array by using a bubble sort algorithm. So let's code it in C. So they have given already some ready-made code. We will follow it. So we will write the code from here. Just I want to make sure that everything is clear. Just for a second. Okay. So we'll code from here. For int j is equal to 0, j less than n minus I minus 1, because in every pass one element will be decreased. So j less than n minus I minus 1 j plus plus. Now we have to compare, right? We will write if condition. If a of j is greater than a of j plus 1, that means they are not in correct order, they are in wrong order. We have to swap them. For swap, we will take one temporary variable, and we will assign a of j plus 1, and in a of j plus 1 we will assign a of j value, and in temp we have the value of a of j plus 1, right? So that will be assigned to a of j. So a of j is equal to temp. So temp value will be assigned to a of j. So this is a simple swap. Now we will arrange these braces so that we don't have confusion. So this for loop ends here, and we have to close the bubble sort function. Now we have to write the driver code, that is the main code. Why it is called driver code? Because the compiler will begin the execution from main. So that's why main is called driver code. So int main. So as you see here, we have sample input at line number 1 in the input line. We have size of the array. So we'll take n. N means the size of the array. We'll scan it. We'll scan the value from user, and we will take the value from user. Scanf percentage %d. We'll store it in the n. Okay. Next, we have to declare the array. The array name is ARR, and n is the size of the array. So this is called variable length array, VLA. Okay. Now, what should we do? We have to take the input, right? We have to take the array elements. So for that, we have to traverse the loop. So we will declare one loop variable called I. Now for I is equal to 0, I less than n, I plus plus, and scanf percentage %d ampersand array of I. So we'll take the input from the user. After taking the input, we have to call the function. What is the name of the function? Bubble sort. With the parameter name of the array along with the size of the array. We have to pass these two parameters. After this function call is done, the array will get sorted. So now we will have the sorted array. Now we will print the sorted array. So for I is equal to 0, I less than n, I plus plus, printf percentage d. See carefully, in each element there is a one space. So percentage d and space, that is the formatting the output, that is the format of output. Now we'll say uh, comma, and where we have to look, array of I, and return 0. Now we will run the code with custom input. Now we will copy this sample input and we will run the code. See the output, we have some okay, we have some semicolon. I have forgot semicolon here, so we'll run once again. One more object. What is the issue here? Each undeclared identifier is reported only for option. So A, okay, sorry. So name of the array is ARR. I have mentioned A. I'm sorry. ARR, 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 ARR. These are the small mistakes. Please, I'm sorry. Run the code. So now we have the sorted array 1, 2, 4, 5, 8. So in this fashion, we will write the code for bubble sort and submit the code. And we got the test cases correct. So that's it for this video. We'll see selection shot in next video. Thank you so much.